Let's talk about solving quadratic equations by factoring. First, let's figure out what we mean by solve. So you're going to be asked to solve a quadratic or find the zero of a function. The zero of a function is basically just the x-intercept. So for example, if I give you this line of the equation y equals x minus 1, all I need to do is look for the x-intercept along the x-axis, and I see that the zero of this function is 1. So we see, or we say that the solution or the zero, they both mean the same thing, is x equals 1. However, if we look at a quadratic down here, like y equals x squared minus 4x minus 5, here's its graph, and we were asked to find the zeros. So we again look at the x-axis for the x-intercepts. We see that it crosses twice. So that means that it has two zeros, -1 and +5. So anytime that we have a quadratic, it will always have, well, most of the time, it will have two zeros. You'll see those two intercepts in that quadratic. Now, just some vocab. The word zero is synonymous to solution and root. And because a zero is just an x-intercept, we really have four words that mean the exact same thing. A zero, an x-intercept, a root, and a solution all mean the exact same thing. So if a problem asks you to find a zero, or an x-intercept, or a root, or a solution, you're going to follow this process here. So let's take a look at this example here. We want to find out what the zero or zeros are of this function given here. Y equals x plus 1 times x minus 2. So we know how to find the zero on a graph. We just look at the x-intercepts. So let's look at a graph. So here we have our graph of this function, and we see that it is a parabola. That makes sense because if I were to distribute this problem here, it would give me an x squared, so it's a quadratic, and I see that it has two zeros at -1 and 2. Now let's look back at our original problem. Remember that our zeros were -1 and +2. See that there is some sort of connection to our factored form here. We see that those signs have switched, but the numbers are the same. Here we have a +1, our zero is a -1. Here we have a -2, but our zero is +2. The reason that this happens is because of something called the zero product property. It basically says if you have any two numbers that are multiplied together and it equals 0, well, either of those two numbers has to be a 0. I mean, think of it this way. If I say 2 times x is equal to 0, well, what does x have to be? X has to be 0 because anything times 0 is 0. The only way to multiply to get 0 is to multiply to 0. So that means if I look at our factored form here, I'm multiplying two things together. I'm multiplying x plus 1 and x minus 2, and it has to equal 0. So that means either x plus 1 is equal to 0 or x minus 2 is equal to 0. So what we need to do is split up our two factors, or those two pieces, and set them both equal to 0. When I solve them both for x, I get my zeros, -1 and +2. So we're going to use the zero product property to solve factored forms of quadratics. For example, I see in letter A, I have two factors being multiplied together to equal 0. So that means that either x minus 3 is equal to 0 or x plus 6 is equal to 0. Solve those one-step equations to get x equals +3 and x equals -6. So we say that the zeros of this function are x equals -6 and 3. we write them next to each other in order from least to greatest. Again, take a look at letter B. I see two factors, so I'm going equal to 0, so I'm going to set each equal to 0. Set each piece equal to 0 using that product property rule, and then solve. This one's a little bit more tricky, but not much, only because it's a two-step. So remember that you undo constants first, and then divide your coefficients. And I'm going to need to do that twice because I have two factors. And I divide here. So we get two zeros of n equals -3 and -2. So again, we're finding those zeros or solving. They mean the same thing. And what that means is we're looking for x-intercepts. We're doing this algebraically now by looking at the factored forms. I have two binomials being multiplied together, set them both equal to 0, split the problem up into two pieces, and solve. Now what happens though, if it's not already factored? Well, that's easy. We're just going to factor it. So make sure that you put all terms on one side of the equation and 0 on the other. Basically, you need to make sure it's equal to 0, otherwise that 0 product property doesn't work. Then you're going to factor, and then finally you're going to find the zeros by solving those little equations. So let's take a look at this example. It works the same as the examples on the other page, except now I need to factor it first. So we need to remember all of our lessons on factoring. Remember that we start by finding a GCF, which there is none here, so that means we'll move to our factor puzzle. A times C on the top, B on the bottom, and we need to find the solution here. Two numbers that multiply to give me 12, but add to give me 8 are 2 and 6. 2 times 6 gives me 12, 2 plus 6 gives me 8. So we'll split up that middle term using the solution to our factor puzzle. Remember to put x's on it, and then bring down the rest of the problem. Don't forget equals 0, that's important. Next, we create our two groups and find the GCF of each. Remember that when you're finding a GCF, all you're doing is using division. So I have the same group now of x plus 2. So I'm going to write x plus 2 in the front of my next line. And when I cross those binomials out, it leaves me with x plus 6. So now we see that we have the factored form of our original quadratic. And now I can use that zero product property rule to split up and say either x plus 2 is equal to 0 or x plus 6 is equal to 0. Solve those one-step equations to get two zeros of -6 and -2. So I say x equals -6, comma, -2. So basically all you're going to do is factored and set some stuff equal to 0. Let's do a couple of examples. Here in letter A, we need to solve x squared plus 3x equals 18. Now remember, your problem has to say equals 0 on one side, otherwise that zero product property rule doesn't work. So first thing that we're going to do is subtract 18 from both sides so that I get an equals 0 at the end. So now I have x squared plus 3x minus 18. Next, I need to factor that quadratic, x squared minus plus 3x minus 18. So we start with our factor puzzle. We need to have two numbers will multiply to be -18, but add to be 3. That's going to be 6 times 3, and then I need to put the negative on this 3 here, so that 6 times -3 gives -18, and 6 plus -3 gives 3. And then we'll split up that middle term so that I have 4 terms in this polynomial here, and that will allow me to create my groups. So the GCF of my first group here is going to be x. The GCF of my second group here is going to be -3. Don't forget about the leading coefficient being negative. That means your GCF also has to be negative. And make sure you bring down that equals 0. I have the same binomial here, so I'll write that first. And when I eliminate those same binomials, it leaves me with x minus 3. Don't forget equals 0. Now that I have factored form, I have two pieces that multiply together to give me 0. That means either this piece has to be equal to 0 or this piece has to be equal to 0. And when I solve both of those in very quick one-step equations, I'm going to get two zeros or solutions or roots of x equals -6 and 3. Now, just so you know, there is a way to check your work here, which might be really helpful when you're working on Edmentum. All you're going to do is graph the original problem and make sure the x-intercepts match your zeros, because that's what a 0 is. Let's check our answer. All right, so I've typed in my quadratic here exactly as it was given to me. So I left the 18 on the one side by itself, and I see that it crosses at -6 and +3. So that means that I made all of the right moves, and I have the correct solution there. All right, let's do a different type of problem. Next, it says find the zeros of f of x equals x squared plus x minus 20. Now here, again, you need to make sure that it says equals 0. It says equals f of x. Now remember that a 0 is really just an x-intercept. Remember that if you have an x-intercept, the y value is always equal to 0. And remember that f of x is the same thing as y. So the first thing that I really need to do here is simply replace f of x with 0. So now I have 0 equals x squared plus x minus 20. Now that I have equals 0, I can move on and start factoring. So again, a times c at the top, b on the bottom. Careful here with that invisible coefficient of 1 for b. And the solution to our factor puzzle is going to be 5 and 4. That 4 has to be negative in order to get a positive 1 as a sum. So we're going to split up that middle term in my binomial or trinomial here, sorry, so that it becomes 4 terms instead of 3. And we move on with our groupings. GCF of our first group is x, and our second group is -4, and we'll factor that out. I have the same binomial, so I write that first. And when I take out those two same binomials, it leaves me with x minus 4. Now we're at the zero product property rule, where I have two things being multiplied together to give me 0. That means one of them has to be a 0. So I say either x plus 5 is equal to 0 or x minus 4 is equal to 0, and solve both of those one-step equations to get me my two zeros of x equals -5 and 4. Remember to use Desmos, use that graphing tool to help you check your work. Another example, this one says find the roots. Again, roots and zeros means the same thing, so we're going to follow the same process. Remember that it always has to equal 0, which I have, so we're good. So we're going to start factoring. Now notice here that we're missing that c value in the standard form of a quadratic. So we might be a little confused on how we're going to move forward with the factor puzzle. I'm not sure what to put at the top. But remember that you also need to check for a GCF. Remember that sometimes you need to factor out a GCF when you factor instead of the or before the factor puzzle. So take a look here at the left-hand side of your equation and look for a GCF, and notice that that GCF is x. So I'm going to factor out an x by dividing, and that leaves me with x minus 6 equals 0. Now this is its fully factored form. There's nothing else that I can do with it. And some students get confused because they don't know where to go from here. But notice I am multiplying two things together to give 0. I'm doing x times this binomial. So that means that either one of these two pieces has to be equal to 0. So either x is equal to 0 or x minus 6 is equal to 0. This is already solved. It says x equals 0. But this one, I do have to do a one-step equation to get x equals 6. So that means that the roots or the zeros or the solutions to this quadratic is 0 and 6. So keep in mind that you might have to do a GCF. Also remember, check your work on Desmos. Another example, we are told to solve or find the solutions of this quadratic. Remember, solving is the same thing as zeros. So we're going to move forward with our process. We need to make sure it says equals 0. So I just need to add 16 to both sides here so that this negative 16 and that 16 cancels out. So now I have x squared minus 8x plus 16 equals 0. And there is no GCF. So I move forward with my factor puzzle. 16 goes on the top, negative 8 on the bottom, and we're going to multiply 4 times 4 to get 16, but now I need to add to get that negative 8. So that means we're going to do negative 4 times negative 4. The negatives will cancel out when I multiply to get me positive 16, but then when I add those together, it will get me negative 8. So let's split up that middle term here. X squared minus 4x plus 16 equals 0. Next comes the two groups. Remember to group that negative sign in front of the sign that follows. And then find the GCFs. When I factor those out, remembering the leading coefficient is negative, that means the GCF has to be negative as well. And then factor out your same binomial. So that's going to leave me with x minus 4. Now notice something strange happens here. I get two of the exact same binomial, x minus 4 and x minus 4. So you have some options here. First, you could set them both equal to 0 because that's what the zero product property says, that either of these have to equal 0. And when I do that and I solve those one-step equations, we're going to notice that I get both of them to be the exact same number. So that means that the solution is just x equals 4. There's only 1 0 here. That means that if I looked at a graph of this quadratic here, it would only touch the x-axis once. It would touch once at positive 4. So what that means is that this is actually the vertex. So it would go down, 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 down on our parabola, hit x equals 4, and then turn back up. Whenever there's 1, 0, that just means that it's the vertex on that x-axis. Now, that's just a fun fact. Just be aware that it is possible to only have 1, 0. Also note that sometimes this will be given as, instead of x minus 4 times x minus 4, they'll write x minus 4 squared equals 0. Because remember that squaring something just means to multiply that thing by itself. So that does mean take x minus 4 and multiply it by itself. So it means the same thing. So you might see something written in this form here, x minus 4 squared. Just be aware that that means you're going to have 2 of this binomial in there. That means that you're going to have 1, 0 on the x-axis. As a brief recap, just remember, put it in standard form first. That means it needs to say equals 0. That should be your first step. Next, you're going to factor. Don't forget that sometimes you need to just find a GCF. Next, you're going to set each piece equal to 0 and then solve. When you solve, it's usually a 1 or a 2-step equation, so those are really easy. And then don't forget that weird solution like we just had, x minus 4 squared. We can split that up into x minus 4 times x minus 4 to get us 1, 0 of that x equals 4. Be aware that there can have 1, 0. Thanks for watching. Hope this helped.